All right, welcome everyone. My name is Jeff Brace, and I am hosting this for TPUG. Today we have André Fachat. All right, did I pronounce that correctly?
Yeah.
Fachat?
Well, close enough. Fachat.
Fachat.
It's actually a French name.
André Fachat. He is here today to talk about his 8-bit retro machines, mostly Commodore PET. He had started with a school computer, a Commodore 3032, but he'll go into more details about his experience and everything like that. So without further ado, welcome, André.
Thank you very much. Good to have you all here and to give me the opportunity to give this presentation. So today I'm going to look over, the Commodore PET, but well, my kind of version of the Commodore PET, what I call the micro PET family, how it came to be, the motivation, and I'll have some demo and stuff. So I hope you're gonna like it. So what was my motivation? When I look at the Commodore 8-bit timeline, we have the KIM, we have the PET, we have the VIC-20, we have the Commodore 64, we have the CBM2s, the TED series, and the 128. So what do they all have in common, kind of? They're almost all incompatible with each other. And that's something that really actually triggered me then in my school days or after my school days to look into what I can do with that. I come to that later. So compared to the Apple, there's the Apple I, but then they have the Apple II, and it's been built in various iterations for even longer time, and it was always compatible with each other, and it has a very interesting expansion slot system for third-party modification, so that's cool. So how did the PET evolve in its own timeline? Basically, we have these 4 types of models. I think you all know them. The original one with static video and the basic one, and then you have the 3032. I think in the US it's 2001 32. I don't know the exact naming of those. Still fixed timing basic tune, and you had the CRTC models, and then finally the 8296, but they all still stayed at a 1 megahertz CPU, then 2 kilobyte video RAM for the 80 column models. So there's really not much evolution inside the PET line. And what could Commodore have made better from my point of view? That would be add an expansion slot system, add more graphics capabilities. So currently there's a lot of work going on recreating some high-res graphic systems in the Classic Computing Forum here in Germany, which is very interesting, but they're all, of course, kind of, again, incompatible with each other. It could have better sound, and it would have been nice if the later systems would have been more compatible. So my compassion for the Commodore PET started at school when I learned programming on a 3032, which is it's a non-CRTC model with 32K RAM. And then I got a Commodore 64, and then I found out some of the games that I really loved on the PET. I was unable to actually port them to the Commodore 64, and of course, in those days, there were no emulators or other machines like the PET. You just could have a PET, right? And so in 1989, I started building a first Commodore PET replica based on Euro PCBs with a MMU for memory management, because my take was always, okay, I can build it one to one, so one exactly the same, but that's kind of boring. So let's see what we can do and improve it. And actually, my multitasking operating system, GeckoS, It's actually built for that machine using the MMU for memory management. And then over the years, there came on a lot of more expansions, like in boards like PC floppies, a SCSI interface, SPI bus, an 8 megahertz CPU based on the 65816. This picture shows a small card, which is okay. Where you can see the mouse. A small card with Ethernet, USB, and SD card, all based on an SPI interface. And then you can already see how the transition to the modern technology started, because the actual functionality is just the right half of the board, and the left half of the board is basically voltage conversion and SPI interface. And this is a select logic. So the actual, so to say, payload of that board is just the second half of it. Yeah. And then, so it was long on my list to get the single PCB PET replica going. But of course, priorities shift and other interests come in, and it was not so urgent. And then the mini PET came out. And I said, okay, I looked at it and said, it's just a PET, exactly a PET, right? And I thought, okay, that was boring considering what I had done already with my Commodore PET clone. And then I started with the release 1, of which you can see a picture here, which is which has the I/O here. Then it's IEEE 488. It still had the unobtainium MC3446 IEEE 488 driver chips. This was a CPLD, which contained the glue of all of that. I had used CPLDs before. This is the CPU, and this is ROM, and this is RAM. And then based on that, and it had composite output. And based on that, I gradually patched it and modified the board until I got VGA output and booting from an SPI flash ROM. And that is where release 2 came to be. As you can already see here, the output has changed. You have the card edge connector for the IEEE 488. You have a tape connector, so you could use something like those adapters that simulate a disk drive using 5 volts from the tape port. And you can see these two here are both RAMs, so it's gone up from 512K to 1 meg RAM. And it had it's not here, so 640 by 480 VGA black and white video output. And it's got all that stuff that I already did on my previous replica, like Ethernet, USB, and it boots from this little flash ROM here, SPI flash ROM. So the CPLD just loads the first page 256 bytes from that flash ROM into page FF of the CPU on boot, and then the CPU does the rest from there. One thing that was important for me also is it's all new parts. So there's nothing you need to pull out of the original PET to get that done. And luckily, except for the CRTC, all of the integrated chips, the I/O chips, and the CPUs are still produced by Western Design Center. So that's a much easier situation compared to the 64 and later. So, but what about the slots and the colors and the extensions or the extensions and so on? And that is where the MicroPET family came in, because then I started working on an FPGA revision. Instead of a CPLD with a higher integration, better emulation of the CRTC graphics modes and stuff. Because the previous versions, they had basically, I don't remember, 1 or 2 registers of the CRTC emulated, because then the CPLD, the programmable logic chip, was full. And then I started with going FPGA, and this is I can show that in real. This is my first FPGA board. Yeah, I had a lot to learn, obviously. And as you can see here, this is not a micro-PET board, but this is a board that plays the CPU board on the bus system that I had since 1989. And so that is also I will also show later that what you can do with that technology there. Oops. So basically now I have 3 systems with the same technology. So one board is the CPU board with only the CPU and the modern technology. As a CPU board for my bus system, I have the micro-PET, which is basically a PET on a single board. It's got a little bit larger than Euro PCB. In all that process, I had to switch from Eagle to KiCad, because my Eagle version was a non-profit version and was restricted to Euro PCBs. And then we have my dream computer, which is the Ultimate PET or Ulti-PET, which is the micro-PET with bus interface plus many extra I/O features. So as I said here, this is the Ultra CPU plus the Ultra bus card here, where it's plugged in, and as the previous micro-PET, it has 1 megabyte of RAM, 512K fast RAM, 512K media RAM, I call it. It's not just video, but it also can hold digital audio data with SD card, Ethernet, USB, which is actually supported in the ROM. I can show you later. Speed is now 17.5 megahertz in its fastest mode, and it's got 768 by 576 VGA graphics with many modes. Like you have ColorPET compatible modes, which I took from Steve's invention of the ColorPET. It has Commodore 128 VDC compatible modes, color mode. Also high-res modes are there. You have sprites and lots of stuff. There's an audio DAC, digital analog converter, with a small DMA engine, so you can you can just tell the system load this data from this memory area into the digital analog converter with that frequency, and it does that with the in the background automatically. USB keyboard mouse support and SD card supports all in the software already. I modified the ROM to have a Commodore 64 compatible kernel jump table, and it's got the extensible bus. And you can actually use my own bus system, which is called CSA. I wasn't very inventive with the names back then. It's just Computer System A. Actually, A65, because, 6502. And then the Apple II RC 2014. So you could use those modules. And it even has a Commodore 64 expansion bus slot connector, but that hasn't been tested yet. And as I said, for the CSA bus, for my bus, there's about 20 different kinds of boards available on my homepage. Apple II has lots and lots of boards. Not all of them are working because, of course, you could basically only use I/O and simple memory cards, but nothing fancy like the Z80 card or anything like that that takes over the bus. That doesn't work. So, but still, lots of possibilities. Also with the RC2014, where we have new cards all the time now. And the micropad, I already looked. I already showed it, and you can see here. This is the cutouts are for the revision 2 micropad. So still missing some cutouts. The board has gotten a little bit larger, but it's the CPU card. The bus interface has been stripped down, so because there's no real external bus, you only need to connect to the 3 I/O chips from the original PET. And I've replaced the unobtainable IEEE 488 drivers as well with 74LS641-1, which do have the enough power to pull the required milliamps per specification. And then we have the Ulti-PET, and that's basically everything combined. Plus, there is a second VIA versatile interface adapter 6522. It has a fast serial bus for the Commodore 64-128 disk drives. It's got a dual SID sockets. It's got RS-232. It's got extra connectors here for expansions like SPI with 5 volts and SPI with 3.3 volt, and it's got this Olimex UEXT connector with I2C. And it's got audio mixer to get all the audio together, and even a small speaker amp. And it's in its Commodore 64 form factor, so you can use that with minimum cutouts on a C64 case. But in the whole process, I don't like taking stuff from existing ones. So I have a bad, a bad conscience, or how do you say? Oops. Because here I actually used a real Commodore 64 case, but I didn't got it. I got it empty from eBay. So, and all other stuff that I used is new, because you can get the Commodore 64 2 cases new nowadays. So how's the architecture looking? You have this big FPGA, which is a Spartan 6 now. I started with Spartan 3, but then found out it's getting out of production. But Spartan 6 has end of life is extended beyond 2030, as I understand. And here you basically have a classical 6502 computer, and then there's the bus interface. You have the I/O here, and then you have the second via the SIDs. You have a double UART. I'm not using the 6551 because it has too many bugs and is not really usable. So just, you probably know, but if you go to 6502.org into the forum and ask, they will explain you all the bugs that this thing has. So I'm using a 16550 compatible double UART. There's an I2C controller on the parallel bus. On the left hand side, there's the video RAM, and this is something slower, because the video is taking precedence over the CPU. And there's the SPI extension bus, flash from USB, Ethernet, and so on. And there's the DUC. And you can see here which is on which machine. I'm not going on to details here. This is the Ultra Bus card I invented. I started, my original bus was all passive. So it was just those connectors and connections, and then. But here you have Apple II card slots, you have RC 2014 card slots, and this is a Commodore 64 card slot. So features, I think I mentioned most of that stuff. By 17.5 megahertz is the fastest speed. You can also run it on 1, 2, or 4 megahertz. All variants have the same graphics capabilities because they are really all the same technology. So they all have the same features, except for, where the extra hardware is needed. Yeah, it's the video controller chip is mostly CRTC compatible, but you can one feature is you can have the index register automatically increment when you access a register on this what I call wiki. You can even memory map all the registers, which actually has 96 registers. It's a mixture from CRTC, VDC, VIC2. Sound is different depending on the version. All of them have the stereo 8-bit digital analog converter, and for the Ultra CPU, you have to use the beeper sound on the PET card or on the dual SID board. MicroPET has the DUC and the beeper output mixed, goes to an analog output, and the Ulti-PET has all that stuff, including the SIDs, and it's going into mixer and then speaker amp. I/O, many boards. Yeah, I think I've mentioned most of the stuff. You can see there's one page I/O, and it's completely full. System control, SPI, I2C, the PET PIA1. I map it only in half of that area where it used to be, because there's the UART and a PET PIA2. Then we have the DUC, the PET VIA, and then there's the second VIA. Then there's the SID boards, and there's the actual video. Software, you can see there's a boot menu where you can actually select which version of the PET you want to run. So you can run the basic 1, the basic 2, or the basic 4 versions, and then basic 4 and 40 and 80 colors. Editor ROMs by Steve, who is in the call here. SD card support is by Michael Style et al., some other guys there as well. I did the USB keyboard and mouse support, and other fixes on the kernel. Third-party color PET games are typically working. I have one here that I use, Grid Runner, games with joystick. Oh yeah, did I mention I have joystick? Yeah, I have joysticks on the machine, joystick ports. There even is an emulator, which is only console-based and has text mode output so far, but and it's still heavily work in progress. And the plan is to get some graphics emulation as well. But yeah, it's not there yet. Demo time. So give me some. So here, what you can see here is, or maybe I'll show a little bit first of all. Yeah. First of all, I can show you here. This is the Ultra CPU card, as you can see here, and together with this card. Sorry, where's the camera? There. This is all the PET I/O. This is everything that the PET needs as an I/O in addition to the CPU card. So actually, you have you can have a complete system like this with the Ultra bus, the CPU card, and then the PET I/O card, and they actually have a RC24 system. And as you can see here, there is an SD card adapter, breakout board adapter here. There's an Ethernet breakout board adapter here. I'm working on a Wi-Fi option here, and this is actually you can run that. You can run PET software on that one with a USB keyboard, because that's all supported. If there's time, I can show you as well. And then let's look at the machine itself. So I have also started working on a case, a 3D printed case, which is it's also work in progress, as you can see. And the keyboard is also by the PCBs by Steve. The keycaps is something I designed and had them printed myself. And then you can see here the whole machine, a CPU, FPGA, joystick ports here. Because the joystick ports are on the user port. There are two different configurations: single joystick or dual joysticks, and there's a poke you can use to switch between those. There's still my bus interface, and I also have a smaller version of the bus interface, and the ultra bus card that I just showed with the other CPU card and PET-IO card. You can actually use that as an expansion bus here. So there is a dual SID. Currently, I have an ARM2 SID here, which is one chip, and a second one, basically empty adapter for the second socket. There is a small circuit that actually implements the shift lock, because you don't get the okay, now I don't know if it's I will probably add an LED for that one at some point, because you don't get locking keys anymore from the from these MX switches. And even if you press the shift lock key for 3 seconds or so, it does a system reset. Yeah, there's all that stuff. There's a 9-volt generation. You can actually use on this board, not on any of the others. You can actually use a real tape drive here. Yeah, and there's the IEEE 488. I'm using my Nano 488 adapter, which is basically doing as a working as a disk drive for the PET. There is an RS-232 here. So yeah. Okay. And the micro-PET. Yeah, there's something. The micro-PET. Yeah. That's so that is basically the same here. You've seen it. I've seen it. You've seen it in the picture as well already. Yeah. So, and this is actually the Tex-Elec keyboard. I don't know if they are still available. I know the mini-PET is not available anymore because parts have expired. You can still build that in 2024 with all new parts. So put that away, and let's get on to some demos. So this is the you can see the screen, right? So
yes, we can see the screen. Yes.
Okay, excellent. So this is the boot screen here. You have the different versions that you can use, and if I say, for example, 2, there's no beep, of course, because that's and the shift block was on. Okay, as I said, I'll probably add an LED at some point. And of course, that's an unmodified. That's in fact an unmodified ROM. And I'll press the key for 3 seconds, and I get back to the boot menu. It actually does have a real reset switch here. Yeah, something dearly missing on the original PETs. So, but even you can use. I didn't test it, but you can use basic 1 actually. And because I'm using a, is it actually working? That's probably not working. Okay, that was a promise too much. Typically, you have the option to use the patched ROMs. And if you use the left shift key, in addition to the selection, you have the unpatched ROMs. So, for example, if I use Shift 8, I'm getting into the okay, I'm getting into the normal PET, and when I do just press 8, I'm getting into the modified ROMs from Steve. Unfortunately, as I learned in the testing, you can't really hear what's going on here on looking at the sound. But I'll try to do that anyway. So maybe you can hear that. That's the SID working. Not sure if you actually hear it.
No, can't.
Sorry?
No, we can't hear it. Sorry.
That's totally strange. Wait. You see, I have this little speaker. I'm holding it directly in front of the microphone. I have no idea why that doesn't go through. Okay. Oops. Okay. So what do I have next for you? Because the memory mapping is flexible. I have a solution where you can actually run virtual PETs, and then you can use the left shift, right shift, and the reverse key to switch between different PETs, so to say. Left shift, right shift, and then there are 4 of them. And the 4th one. And then back to the first one. Of course, they don't run in parallel, like in my operating system, but yeah, that's something you can do. Then let me show a little bit of the graphics demo. So you can see here borders and raster line interrupts. You have the VDC color modes, color PET mode, multicolor modes from the VDC. You probably don't see it on the screen now, but usually only every other raster line is being painted, so you get that line type video CRT feeling. But you can also have interlace mode where every line is painted, and then you can actually use 50-row modes. So you squeeze that together. So in total, you can get up to 96 characters by 61 or 62 chars. 62, I think.
Andre, I just want to interrupt you for 1 second. So someone suggested that you turn off the noise cancellation to be able to hear the audio. Maybe that's why that's not coming through. It's some sort of filter, the noise cancellation. But
could you tell me how?
All right. No, well, don't worry about it right now if you don't have to. So far, I can see what you're doing. It's pretty cool.
Yeah, the demo doesn't have any sound anyway. It's work in progress. I would have liked to, do the demo with a whole screen, but I haven't gotten to do that yet. So the only idea I had to just move that stuff around a little bit so you can see you can use the whole screen for video output, and it's got palette, and then you can it tries to show off all the color modes. Like you can see here that it has different color shading, so it has palettes that you can switch, and so that's then you have the sprites. You have two palettes you can switch between. Sprites have a bit that you can that they can have palette 1 or palette 2. Also, they have a bit if they should show up over the border or under the border. So things you have to do really. You have to go through a lot of hoops on the Commodore 64. Much easier here. So then, what else can I show? Okay. You can see there's the game Grid Runner. Strangely enough, here the joysticks don't work. I don't know why, but then you can hey. And unfortunately, you can't hear the sound again. But yeah, this also has sound, so it's actually using the color from the color in the color pet mode. So that's really nice. And there is the other mode like Petaxian, and then I can use my joystick here. And then I can play. So joysticks work. Yeah, unfortunately, as I said, the sound doesn't work. I could probably show you my GeckoOS demo, but that's a plain only the 8296 as it's done. So let me get back to the presentation. And how do you get that? Everything is open source. There is a parent repository on GitHub. That's that. There's a QR code later, so if you want to show that, you just check that out on Linux. You probably it works on others as well, but then you run make clone, and it pulls in, I think, about 10 other repositories or more, even sub repositories. Like the ROMs repository pulls in the editor ROM repository and the SD card support repository and the USB support repository and all that stuff. For everything, there are Gerber files and bill of materials with Mauser part numbers. I know Mauser is maybe not the cheapest choice, but for me, it's a one-stop shop. So, but it's a starting point. Yeah, you get, and I think the only thing that's still in Eagle is the Ultra CPU, but the others are all in KiCad already. But Gerbers are there for everything. Yeah, so that concludes the actual presentation. So you have a modern PET replica. You get all new parts in 2024, up to 70.5 megahertz video. Well, you've seen it all. There's the QR codes if you want to grab the stuff. There's the first one is for my YouTube channel. I haven't done a current presentation on this one, so basically you are the first ones that get it over the internet. I've given that presentation on the Vintage Computer Festival Europe a couple of weeks ago in Munich. Yeah, but this is the first where it's on the internet, and this is the second QR code is for the GitHub repo, where you can find everything.
All right,
So,
great. Andre, so do you want to take questions now from the?
absolutely.
All right, so everyone, let's have. Can you, since you're in a Google Meet, you can do the virtual hand. You put their hand up, and then I can let you talk one at a time. So does anybody have any questions right now for Andre? All right, so Marcio, do you want to ask him, or you want me to ask for you? Well, he says, can you please demo some of the audio capabilities? Go to the microphone icon on the bottom, click on the up arrow, which opens up a small strip above on that right. On the strip on the right, click the gear to the settings, turn off noise cancellation.
Okay. Here. Okay. There. Thank you. That's good. Okay, let's try. Interesting. So.
Oh yeah, it's filtering on things that are not speech.
Okay. Now.
Yeah, now we can hear it.
Yeah. Finally. So let me show you how that all works. So here's the actually this is just a small audio amp. It gets its power from the USB port, which is not used here in a moment, and then I have a little audio connector here, and then when I can connect it here, and it's actually louder now, because what you've heard in the first one is just the beeper, which is still here. Yeah, but you have to use the audio here for the to get the mixer output, and the mixer mixes the dual SID and the beeper and the duck. Yeah, so that's wait. So this loads a small digital audio file, and then you probably recognize the song.
It's a 80s song.
Yeah.
Something like that.
Yeah. I think it's about 8. I have to look at the files, how large they are. Yeah.
Yes, I recognize that.
So that's digital analog files, and if I would remember the poke from the, I could rerun it with a single poke because the DMI works, but I have forgot the poke. So let me. So that's SID sound. You hear that?
Yes.
It's probably even too loud now, right?
No, it's not too loud.
Okay. Of course, Rob Hubbard has to be. This is the reason I use this is actually because I found a player in source code where I could patch in the different SID addresses. And then we can actually try and see. You can hear that.
Right now, no.
Sorry?
We can't hear anything right now.
Yeah, no, not now, but now. And this is actually beeper sound.
We can see you in the keyboard. You do want us to show the screen too?
Oh, sorry.
So this is Grid Runner.
Yeah, and this is actually beeper sound. But it's going to the mixer, and that's why you can hear it on the amp here. Yeah.
Very good.
All
right. We have Steve has a question if you're ready for it.
Yeah.
All right. Go ahead, Steve.
Can you show us anything that is accelerated to 17.5 megahertz? Anything to show the speed comparison?
Actually, yeah, I can. Actually, the demo was on. Oh yeah, I can. Yeah, this is a good point. That's a little program I wrote. So no, I need to use the 80. No. Huh? I don't wait. Yeah, when shift is on, you get the unmodified. Yeah, so I need an LED for that. Yeah, I know what's happening. Sorry, give me a sec. I need to go 80 columns, and probably I need to go. Let's make it sure that it works. Let's go unmodified ROMs. So that's a small benchmark program I wrote. It uses the 60 hertz screen refresh as a master, timing master. And then it calculates how many cycles the CPU has during that 60 hertz or in one screen refresh, and calculates the speed of the CPU from that one. And the normal one is because it's running at 17.5 megahertz divided by 16, it's 1.1 megahertz. And then you can get the CPU speed test in the fast RAM. And you can see here, this is the system. That means the VIAs and all that stuff, they always run at 1 megahertz, 1.1 megahertz. The CPU runs at up to 16 point something megahertz. So, in fact, the original MicroPET had the I/O run at full speed as well. But to unify the architecture and everything, and because I had to do the 3.3 volt conversion for the FPGA versus the 5 volt for the I/O. Anyway, so I decided in this final architecture, the I/O runs at 1 megahertz in the I/O frequency, and then only the system and the fast RAM goes in 17 megahertz. And this is in the this is in fast RAM test. It tries to look at the effects of the several screen how several screen settings affect the speed. Of course, in fast RAM it doesn't, and in video RAM test it doesn't as well. It's probably because this is still running on old register values. I changed it, but you can see here, if you're running code in the video RAM, it only goes up to 7.3 megahertz average, because the system runs in lock with the video output. and the system runs in log with the video output. You have 8 pixels, and the pixel frequency is 35 megahertz. And you have 2 pixels is 1 memory access. That means 1 byte or 1 character has 4 memory accesses. And for the video, you actually need 3 of them, which is first, you get the actual character, then you get the attributes, which is either color or blinking stuff and so on. And the third one is it's actually fetching the character ROM, which is not a ROM anymore, but just the definition of the character and it's stored in RAM. And only the 4th access is reserved for the CPU, or is then available for the CPU. And if you have audio output, there is still some missing there. Then there's some additional cycles going missing if you run sprites. But it's not about 4 megahertz, because you of course have the off-screen areas where you don't have the cycles taken off by the video. So on average, then it's 7.3 megahertz. Also, I can show you something. Shit. Because yeah. Okay. Ignore. Wait. Ignore. You don't see it because there's just there is the color. But let me try something. Okay. Because what I did, I took an old burn-in test program, and I modified it, I modularized it, and you can have you can see all the burn-in tests, and it has automatic detection of the system. So you see it's an Ulti-PET version, not a micro PET. It's got a 658016. It's got 17 megahertz. And you can also see here, this is banks 1 to 7, banks 9 to F. You can't test them that quickly in 1 megahertz, because that's all 512 kilobytes almost. Yeah. Ignore the IEEE 488 errors, because they happen because there still is a virtual disk, there's a disk drive attached. And the RTC. Oh yeah, it has an RTC chip here as well. So there's a connector for a battery. You can have the clock in there, but this is not supported yet. So that's also running at 17 megahertz, because burn-in should be as fast as it can be. I can also show you one thing more. So now I'm taking out the audio thing here. I'm putting in the USB keyboard. Yeah. And then I am using a USB keyboard here. And Control C is break. And you can actually you can use because this one has a combined keyboard and mouse. You can also use the little track point here as a mouse for the cursors. Yeah. Further questions?
Very cool, Andre. So, does anybody else have any other questions for him? So you said you can, people can buy this hardware. Is this just you just supply people with the list of parts in the software? Is that what it is?
Yeah, I just don't have the capacity to actually do sales and stuff like that. So everything is open source. you can take the Gerber files, give them to a PCB manufacturer, take the bombs, get everything from Mauser and solder it yourself. Which is a challenge, of course, because this is very fine pitch SMD work, especially for the FPGA and some of the other chips. I want to create a project with JLC PCB or PCBWay, don't know yet, where you can basically get the board with all the SMD parts already soldered. Because even with my experience, this MicroPET here has again gotten a bad cold soldering joint.
Yeah.
So I have to resolder it again, which is annoying because I have to do that until next week, where I'm on the classic computing event here in Germany.
So do you think that it's possible that you could have like someone could potentially have a kit or full of parts, which they could, if you gave them instructions, like I'm thinking like of a classroom environment where here's a kit full of parts and software. Do you think that's like something that could be possible? They could be, someone could just like, all right, here, and then it would follow step by step on how to build it. Is that something that's possible?
In principle, yes, but I wouldn't recommend the SMD parts to be soldered in a classroom or so, because those are really fine pitched. Not sure if I can show you. Let's if you can look at this. This is it's not it's not doing the focus, but this is 144 TQFP, so it's 0.5 millimeters distance, and the USB chip here and the RTC chip here, I think. And on the big one, there's the I2C controller, which has the same pitch, and the UART. That won't work on a classroom, I think, because you really have to have experience with soldering.
Yeah, so maybe some of those things might have to be done.
But if you have the kit with SMD already soldered, I don't see any problem.
All right, I have another question here from Roxanne. Any chance that you'd be willing to share the STL files for that 3D printed case?
Yeah, sure. Yeah. The point is, right now, if you look at this, this is almost perfect right now from the location of the openings, except for the power supply switch. I have to move that a couple millimeters, then it fits the Commodore 64 location. Otherwise, you can actually, the only thing you need to do is this opening here for USB and VGA, basically, and the rest more or less fits. Okay, the user port is on the left-hand side, and the RS-232 if you don't need extra user port because you have the joystick already there. You could basically use a Commodore 64 case. The parts for the keyboard are already there, and what is still missing is there are no. You can see. Wait.
You have to switch.
Yeah. You can see here. This is improvised gluing together, because my printer I can only do half of that case. So there is some parts that you can use. I have a small video. I'll put that up on my channel in the near future. How you can glue that together, because those squares, one is on this side, this one is on this side, this one is again on this side, and you put in some hot glue, and then it's actually pretty good. But here it's still not working, so the next revision has here and here. So this is still in work in progress, but will be shared definitely.
All right, wonderful.
There you have this is the previous prototype, by the way. So
it looks like a Commodore 64C type board.
It is not. It's actually longer.
Ah, okay.
It's actually longer because, I wanted the keyboard supports not to be separate parts. So this is printed in, and I typically print that on the side, and then to the half height, and then the other one this way, and then I can glue that together. That's how much my printer can print. I'm currently having problems because it clocks all the time. So otherwise I would have had another. And then what it doesn't have yet is doesn't have any parts that actually hold it together.
Oh yeah, no interlocking parts to click it.
Yeah, exactly.
Okay.
So that's but yeah, it will be shipped.
Yeah, the 64C, and then I think it had something where it locks in, but those are easily broken off if they become brittle and they break off.
Yeah, and Steve can tell stories how we both tried to get Commodore 64Ks adapted, and it didn't really work out because he used a certain 3D program, and if I remember, you can print it, Steve. But
Steve, do you want to say something about it?
But I had to modify it, and I couldn't use his program. Or when I used his program and tried to put it in, it had some logical errors. Like it said some parts were not solid, and then that didn't really work out. And then I imported it into Tinkercad and then tried to fix it there, and so I gave up on that and created my whole new own case for that. It just this afternoon I actually threw away all the other prints. Oh wait, no, there's one. This is one of the last tries, but yeah, so. And this is the revision 1 micro-PET in it. So, but we didn't really succeed in getting a top of that for that case printed, and so yeah.
So Roxanne wants to add she would be modding it, the 3D printed case, for use in an unrelated project as the basis for a cyber deck built from a C64C board with some alterations.
Sorry, I didn't get it. You want to use that for an own? Yeah.
So she's going to be using it for some unrelated project, for a cyber deck. I don't know what a cyber deck is, but
I don't know.
All right, Dan, did you want to say something? You had raised your hand and then it went away. So Steve, by the way, Steve says, I'm still working on the C64 and C64C 3D models, which will be released when they're working. All right. And Dan says he has some 3D printing, and if a mesh is not working, you can fix it on a print.
Yeah, but frankly, we invested, both Steve and we invested so much time into trying to fix this stuff. And it still didn't work. I mean, we're both beginners, if I may say so, Steve. We're doing such complicated models, and yeah. So I mean, on the other hand, like these keycaps, yeah, I did them in Tinkercad. I used the generator for the actual key part, and then I digitized all the characters and put them in as engravings on the keycap, on the actual keycaps, on the front and on the top. I had them resin printed with a service provider, and then I took some alcohol color and applied it on the keys into the engravings, and then tried to clean it up. You probably don't see it, but some have more shades of gray on top than others, where more glue is more color spilled over. But yeah, I think it's still very nice.
Roxanne said the CyberDeck is a custom portable. That'll be
Yeah.
interesting. It sounds interesting in any case. All right. Is there any other questions anybody has?
Yeah. One comment on portable, because actually, you've seen it. This is this basic cries for something like to have, folded
Portable top. Yes. Yeah, a top to fold and click shut and have a handle and carry it around. Commodore portable.
Yeah.
All right, Dan has a question. What are the best ways to follow your work?
Yeah, the best ways is basically public. You can go on a video series.
Yeah, you have a YouTube channel besides the 6502.org?
I'm not the owner of 6502.org.
So it's just a sub channel.
I have a sub page, users André.
Okay. And you have a
this is actually updated less regular than GitHub. So GitHub is where I work on. The video series is where I do some publications. I have a Discord channel. I haven't. If you give me an email, if you send me an email, I can give you an invite.
Okay. Where could people email you, or do you want to just post it to the TPUG mailing list? You can always do that, right? Or does it have to be, or is it individual emails to each person?
Yeah, I'm not that good at Discord yet.
I think usually there's just you have one invite. Sometimes there might be times where it expires. But
yeah, exactly. It expires. So I think on my website there. I mean, I can let me.
Steve says he's still working on a portable, and Roxanne says, "Very cool, Steve. I love making interesting machines to confuse the general public."
Oops.
Infinity and beyond. All right. Well, very good. Is there any other questions before we wrap this up? We thank you very much, Andre. This is very interesting. I like this. A very cool project. And I understand as an individual, you can't really, sell this thing, but this would be something that people would love to have. And
yeah, absolutely. I think so. I would be happy if someone would pick it up. And do something like that. I mean, the best I can do is, but it will take some time for me, maybe until Christmas or so, to get a project on one of the providers, Chinese providers, where you can get on board with all the SMT parts.
Yeah, the work that you've done is at least a lot, because it's sort of like you filled a need. Necessity is the mother of invention. You needed something to be, originally to run your PET programs on your 64. So you found ways to create these emulators and clones to make it work and to be able to switch between different modes and things like that. It's really, really wonderful, amazing. All right. Well, thank you, Andre. It looks like there's no more questions from anybody. TPUG, thank you for this talk, and we'll see you around.
Thank you, everyone. Thanks for having me. Glad I could present it. And yeah, I would be happy if you could join my Discord and follow on me on Twitter. No, I'm not on Twitter anymore. On YouTube and or Mastodon. Yeah, whatever. You
All
find me. I mean, my name is unique, so, and I'm not covering under some kind of pseudonym or so.
Yeah, it is unique enough that you're not going to be confused.
As far as I know, it's actually worldwide unique. So.
Yeah, I've never seen it before. It's not like John Smith, which is very cool.
Yeah.
All right, I'm going to stop recording. Thank you very much.
Thank you, everyone.